Hey, everyone. I'm about to dive on exercise number 5.2 now. Okay, let me read it through. It's been a long heck of a day, you guys, and no wonder I'm yawning. I've been doing too much exercises lately. Okay, so a number is called a perfect number if it is equal to the sum of all of its divisors, not including the number itself. For example, 6 is a perfect number because the divisors of 6 are 1, 2, 3, and 6. And 6 is equal to 1 plus 2 plus 3. As another example, 28 is a perfect number because the divisors are 1, 2, 4, 7, 14, and 28. And 28 is equal to 1 plus 2 plus 4 plus 7 plus 14. However, 15 is not a perfect number because its divisors are those numbers there, 1, 3, 5, and 15. And 15 is not equal to 1 plus 3 plus 5. We gotta write a program that finds all 4 of the perfect numbers that are less than 10,000. Okay, and I've already created this file, you guys, for the sake of speeding things up. So here is the game plan. I'll have a for loop which will have numbers starting from 1 all the way up to 10,000. Remember, you guys, because I also want to include 10,000, I need to add 1. Okay, so go sum of divisors, a variable to hold the sum of divisors. At first it will be initialized to 0. I'll have another for loop which will look for divisors. So divisor in a range, I'll start from 1, I'll go all the way up to number divided by 2. Of course, it would be a good idea to go all the way up to the square root of a number. There is a more efficient way of doing it, but I don't want to create confusion for you guys. Let's keep it simple. I'll go starting from number all the way up to halfway through of the number we're currently working with. Okay, so I'll have to add 1 in order to include the half of the number as well. I'll then now check if number mode divisor gives us 0. In that case, if that case holds, then I'll have to add divisor to sum of divisors. Okay, if number mode divisor gives us 0, then we know that divisor is a divisor. That sounds a little bit weird, I know, but you get the point. Okay, once that for loop there has finished running, I'll have to check if sum of divisors is equals to number. Nope. Oh yes. If it is indeed the case, then I can print out number. Then I know that that number is a perfect number. Now let's hit the run button and see what we get. You know what, you guys? I know why it's only printing the first 3. It's probably because give me a sec, you guys. I want to check why is it only printing? Isn't we were told that there are 4 of those numbers? 10,000. Why is it displaying the first 3 only? Is it 10,000 or 100,000? I'm starting to doubt it now. Okay, give me a sec. I cannot believe how stupid I can be sometimes. You see, before I did this, I waited. It's not like you see, the program is still running in the background, you guys. Okay, so here's what I'll do so that you'll see that we will. You see, once this loop finishes, I'll then display it done. For a slightest moment, I thought I've got a logical error. Let's wait now for the word done to get displayed. Of course, it's gonna get displayed immediately after the loop finishes. We're still waiting for the last number, which is that one right there. Again, you guys, you know what? It will make sense. Do what? To just go. You see, on each iteration, what I want to do, I want to display number, right? On it's just that it's gonna be sort of messy. Okay, so let's see. I want to display number. Number is, oh, let me just go number followed by a dash followed by the sum. I mean, it's divisors, right? Okay, so once I'm done doing that, once I get a divisor, I wanna display it. Display divisor. Okay, followed by a space. Okay, on each iteration, what I will then do, once the loop finishes, I will go to the next line. Okay, once the loop finishes, I'll go to the next line. Now let's see. Remember, you guys, the reason why I'm doing this is so that you guys will see that those numbers there are the correct ones indeed. You know what, this is taking too much time. I'll pause the video and show it to you once it's done. There's no way in hell, you guys, I'm gonna wait for this thing to finish. You see, I've already waited more than a minute now, and yet it's still dealing with 165. It haven't reached even 200. You know what, I'm gonna terminate this. What I'll do is, again, remember, because I'm over the solution now. It's just that I want to show it to you that these solutions work. Okay, I mean this solution works. Okay, oops, that's not how you comment in Python. Okay, let me display those numbers first. So it's 496, right? And 8. What I want to display the divisors for those numbers so that you guys will verify that I've got a working solution. So it's 496 and 80. Okay, now that I've got those, we know it's easy for us. We were shown here to see that 6 and 28 is one of perfect numbers. Okay, so in order for me to verify my solution, it will be wise to go I can print that. This time around, though, what was the number, you guys? 496, am I right? 496. Let's go 97 so that 496. Okay, we're going halfway through, right? Really? That gold is making noise. Okay, you guys. Not sure whether I should. Oh, let me display them horizontally. You know what? Let me get rid of that right there. Oops. Undo. If again, you guys, I'm trying to show you that I have a working solution. Feel free to skip this if you believe me. You see, these are the numbers that make up these are the divisors for the number 496. Okay, if you sum them, you can do it yourself. You'll see that we get precisely 496, which proves that it is one of the perfect numbers. Now let's see if I do that. Now I forgot what was the last number. I wanna verify it now. Thing is, you guys, the reason why I'm trying my best to show you guys that I've got working solutions. Some people, they've got a tendency of spreading rumors that I sometimes give out incorrect solution. In fact, it's something that happened once a while ago on my YouTube channel. It's just that ever since I always want to play it safe. Okay, so it's 81. Ever since, you guys, I always try to make sure that I've got a working solution, right? I uploaded a solution with a logical error, so that became a big deal, you guys. Where in the holy hell did I? So the number is 8128. 8128. Again, I'm doing this to verify that the sum of its divisors is indeed 8128. You can check it yourself, you guys. I'm not planning on doing it, right? Yeah. Now that you are probably certain that I've got a working solution, I can get rid of that part and leave my solution as it is. Okay, so that's gonna be it for this tutorial, you guys. Cheers. I'm